Hello everyone. Today we are going to implement removeLast method in our DoublyLinkedList. Format is same. First we will do a pair programming or coding, and then after that we will execute the some use cases on a whiteboard so we can understand what is going on under the hood. Fun remove last. So again we have two options here. Throw an exception if our client call invoke this API, or maybe return null if it's invalid. So I'm going with the null option. Okay, so edge cases, empty, list is empty, then one value and multiple values mean nodes. Okay, so I think these are the only three edge cases. In case of an empty, what we can do, we can directly check if is empty, return null. Then if there is one value, in case of a one value, we can go back to our philosophy, try to reuse already existing implementation. So in that case, if I have only one value, it means it's a one node which is head plus which is also tail. Like this one, tail is equal to head. Basically that is the condition which we are looking for. So in this case what we can do, I can say size is equal to 1, then return remove first. So in case of 1, it will go towards the remove first, and from there it will complete everything. Now the last is simply multiple values, means I have list of 1 2 3 4. So 1 is head, my 4 is tail, and what I'm looking for, I want to move our tail at 3. So in this case what I can do, tail, you should be moved back to the previous node. So before that tail is 4, and after once this one is executed, now tail is 3. Okay, and after that, to make sure there should not be any memory leak, what we need to do, we need to say okay, tail dot next node equal to null. And okay, one more thing I forgot, the value which we will take from tail and return. So in this case, 4 is a tail, then I'm saying okay, tail, you are going to move previous node, now tail is this, and now at this point I'm saying okay, tail, your next node should be null. And also there will be a memory leak, same just like we saw in the remove first. So we need to do tail dot next node dot previous node equal to null. And then, like, you can imagine easily, so this is 4, or maybe we will see on a whiteboard. So 4 previous is pointing to this, and 3 is next is this, and 4 is null, 4 is next is null. So in this case what we did, we are saying okay, tail, you move back, so tail is now here. Then I'm saying okay, tail dot next node to 4 to the previous, please make sure that is null. And then once that is null, we have the last one, tail dot next, and after that there will be no memory leak. And here you can see the one benefit of doubly linked list. It's a big of one operation. If you guys remember, in a singly linked list, remove last is a big of n operation, because we don't have the second last uh, node, so we need to do a loop. But in this case, because we have a pointer, so it's always a big of one. So it's time to check if what we implemented, is it working or not. So I think we can use the previous examples, only I need to change the remove last. Then we did this, and in this case I added one value, remove last, and then here we added multiple values. So we will see. So first is null. Null makes sense. Then we have a one value, one and null. Then we have a 4 3 2 1, and once we will remove, it's removing one, the last one, and then after that we have 4 3 2, and 2 is null. And to make sure there is no memory leak, what we can do, we can test debug this. Plus, can we improve this? So in this case I can see, oh, there is a one bug which we forgot, size minus minus. Oh yes, this one is important. So we need to do size minus minus, and in this case is empty. If I do, or oops, sorry, size is equal to 1, then call remove first. So in this case what will happen, if it's a empty or is equal to 1, remove first. So remove first will go there and it will check is it empty, return null. So I'm trying only this, and still functionality should be same. Then what we can do, now we can check if there is any memory leak, and that we can do in the same way, temp and put tail before moving here. And now we will try to check what will happen once we are going to run this. So at this point we have head, next node, next node, next node, and then null. So we have 4 3 2 1. 4 is our head and 1 is our tail, and tail basically means 840. So 840 is this node. Then I'm moving temp to also this, so we can confirm if there is no memory leak. After that I'm saying okay, tail, this one, and this, you need to move to the previous node. Previous node is 842, I think so, 842 I think so. So it will move to the 842. So we are able to move, and now currently tail is saying okay 2, and then it still have the 1 next node. So I'm saying okay, you need to cut your next node. So now in this case tail is 2, my next dot previous node is null, tail dot next dot previous node, next node dot previous node, and then after that we did this. So in this case now what will happen, we have temp, first temp is now independent, there are no previous node and next node, it means it's ready for the GC. In case of a tail, we have now 4 3 2, and our tail is currently towards 2, and next node is null and the previous node. So everything is working as per the expectation, and again this is a big O of 1. Welcome back. So we can start from the edge cases, like the edge cases or use cases, how client can use. So there are, just like we saw in a code, we have three cases: empty list, one node, and multiple. So in case of an empty list, this is our size, which is equal to 0. We have our head, we have our tail, both are null. So as initialized doubly linked list by the client, it's null. And if it is called remove last, in that case, you guys remember, we have a check if it's empty, or maybe if its size is equal to 1, try this to remove first method. In remove first we have a is empty, so return null, so this will be null. So I think this one is a pretty simple. Then once we have a one node, so we have null, previous, and next, and our head is referring to this and tail. So basically in this case what we did, we tried our remove last method to remove first, and remove first we already discussed in a last video, so I'm not going to explain again, so you can watch that. Then now we are moving towards the multiple. This is a one scenario which is different from the remove first method. So in this case we have nodes 1, then 2, and then 3. So and this is our tail, this is our head. In this case, what we did in case of a multiple, we have a code if is empty is 1. After that we have a value. In this we are going to say okay, tail dot value. So in this case this will be 3. So it means we are returning this 3. After that what we are saying, okay, tail, your tail, you need to move here because we want to delete this node. So what we write in our code, tail is equal to tail dot previous node. So tail dot previous node is assigning to tail, so it means now we are at this. Now we can see from the picture we need to delete these two nodes, this node and this node. For that what we can do, first I can access both. So what I can say, okay, tail, your next node to the previous node, do null. Tail, your next node dot previous node equal to null. Tail dot next node dot previous node is null, which means this is null. Okay, then I want to remove also next. Tail dot next node equal to null. By doing this, our list is now size 2, before that it's 3, and now it's clear GC can take this. So garbage collector can easily take this and release the memory, so that memory we can use again. And the benefit in so in this method we can see we have a big O of 1. Every time you come, we don't care how many nodes you have. And how we tackle how we get this big O of 1, because in single linked list it's a big O of n operation, because we have this previous node which is very powerful. Yeah, on the other side there is a space complexity. We are taking 2 extra pointers, but if in your use case you think you are going to use a lot removeLast and anything around that, it's a good candidate, but be careful because it's space expensive. Then yeah, I think for today it's complete. So I hope we learn something new. See you tomorrow in the next video. Bye.